Microsoft Mesh is Microsoft's platform effectively for metaverses and metaverse development. So I am working on that product. This is my email address, my Twitter handle, my 2 blogs. To be completely transparent with you, and the legal team has me throw this up. The content of this presentation today is my own personal opinion. This doesn't represent an official statement, opinion, product direction, or announcement from Microsoft. So please understand, this is Jared's own personal view of where the industry is going. Okay? But why I'm here today is to try to talk to you about and give you some advice about things that you might want to do in your career over the next couple years if you are interested in landing a job working on metaverses. Okay, so I will talk to you about some of the technology that's being developed. I'll talk to you about what I consider are some of the key ingredients for successful metaverses, and then things that you can do in your school planning to kind of prepare yourself for one of those roles. Okay? So these are the things I'm going to talk about today. I'm not going to read them, but these are all the topics we are going to cover. And at the end, jobs. All right, so let's talk about the ingredients that I feel need to be there for a successful metaverse. And the first one that I want to talk with you about is presence. Now, if you've been playing around in VR for a while, presence in general is the feeling of being somewhere. Okay, it's the feeling that you're actually visiting a place. But when we talk about metaverses are inherently social as well. So it's not just like the presence of being somewhere, but it's the presence of being there with people that you care about. Okay, so I want to talk a little bit about potential career paths and technology that have to do with the presence. And the first one is hand tracking. And we all have hands, we all gesture. I'm up here gesturing a lot, point at things, okay? And so I think hands are going to be an important part of presence. Whether or not you're doing sign language, even if you're just talking with someone, hands are an important part of presence. Hands allow you to grasp things, hand things to other people. We'll see a video of that later. So artificial intelligence, if that's a career path that's interesting to you, is a big part of hand tracking. And let me pull up a document here to explain why. This document that I'm pulling up is a research paper published from Microsoft last year. And we have this kind of problem. Whoops, I'm already down further. We have this problem when it comes to accurate hand tracking of diversity. Not only do we have different color skin, we have different size hands, we have different wardrobes, sometimes long sleeves, sometimes short sleeves. All these different things we have to account for, lighting conditions we have to account for. So it turns out that machine learning is really the only way to solve this problem. You can't write classic code to solve hand tracking, okay? But in machine learning, how do you come up with the data? So anytime you have machine learning, you have to do what's called data annotation. And here's an example of knowing where the different bone structures are, knowing where the different points of the body are. This is called a segmentation map. So segmenting what's the left arm versus the right arm. And traditionally, a human has to go and label those things. Very, very time consuming. Wouldn't it be great if we could just make up thousands of virtual people that look like real people, but are digital people, because then we have all of the annotation that we need. We know the data is good. And so that's one of the things that Microsoft Research is working on right now. I don't need my pop-up there. So what we do is we start with a hand, and this blue hand here is actually a model of a human hand. It's not clear here, but it has bones in it. It has the shape of the hand and everything. Okay, so we know where all the joints are. And then we have somebody sit in a custom rig, and they capture like 97 different hand shapes, 148,000 different hand poses, recording just different wavings of hands and gestures and all that sort of stuff. So we have this recording of one person doing all these gestures, and we can fit that hand. So what you kind of see on the screen down here are all these tiny little dots that are recorded by the cameras watching this person do all those gestures. And then we fit the hands with the bones in it to the scan. So now the hand is doing all the gestures that the human was doing. But on top of that now, we can virtually model hands, do full-blown light simulations. We can put different skin tones. We can put watches, different articles of clothing, different lighting conditions, different backgrounds. And we can have thousands of virtual people doing the same poses with different outfits and different lighting conditions. And then we can go and train our AI models because our AI models now know the hand pose. So what you're seeing here, this is actually kind of the final output. So it turns out on HoloLens 2, we don't track hands with the color camera. On HoloLens 2, we have a infrared depth map camera, but this is simulating what the HoloLens sees. Notice the arms are cut off. Those aren't real arms, but we're simulating what the HoloLens would see if a person was wearing these outfits. And then we know the bone positions, so we can then turn around and train the model. Okay? I'm going to come back to this virtual human thing in just a moment, but yes. Yeah, HoloLens is Microsoft's flagship augmented reality. Even that's kind of short selling it. We like to say mixed reality because it's not just showing content on the world, but it actually understands the world. It understands the shape of the world. It knows where a table and the walls. It knows how to track you throughout space. So that's kind of our flagship device for understanding of the environment that you're in. Did you have a question?
Yeah. Is there like latency on this, or does the headset do it?
Okay, so when it comes to machine learning, and the question was, is there latency on this? When it comes to machine learning, you try to use your data center, your really powerful machines, to train all this data, and what comes out of it is a lightweight model that can run really fast on mobile devices. So you spend a bunch of compute up front to generate your model, and then that model runs in real time on the hardware. Okay? So definitely, if you're interested in Metaverse Careers, machine learning is a path for you. And to give you another example, I want to talk about avatars. How photorealistic are avatars today? I don't know who's used like VR chat or AltSpace, or they're all cartoons, right? All very low fidelity, which makes sense because we're trying to run these things on mobile class devices. But going back to that recipe of presence, I mean, at some point, if you want to feel like you're actually there with somebody, you want to be able to see that person. You want to be able to see their facial expression. Okay. Now, Microsoft is working on this in research. Meta is working on this in research. I'm sure there are a dozen other companies out there working on this in research. But I wanted to show a short clip to you about kind of some of the latest stuff that's being done by Microsoft in this area. And maybe.
Instead of free photos to train a new AI to do useful things with them.
Okay, so remember the virtual human thing that I just showed you? Same technology, same data set, but now we're looking at faces. Faces in different lighting conditions. Okay? And what, I'm going to skip forward here a little bit, but coming back to that data annotation, in fact, let me just mute this and talk through it instead. Because this is a virtual human, we know certain things about this human that would be hard to annotate, right? Like we know where the eyebrow is, even though the eyebrow is occluded by the hat. So we can train a neural network to detect and predict certain facial features, even if those facial features are covered up. So let's take a look at, oh, and by the way, the technique that we're working on now, this is the current technique in Microsoft Research, has 370 different facial landmarks. That's over 10 times the number of facial landmarks of the previous method. And on top of that, we can also try to do it with occlusion. So let me find that part of the video here. Okay, so trying to predict what that facial expression is, even though their face is partially occluded by a headset. Okay, now obviously we can't guess what's going on under the headset, but based on whether or not they're smiling or frowning, we can make the neural network can make a guess about what the eyes are doing. Okay, now the last thing that I want to show, and again, this is all feature stuff, right? Like this isn't happening on any mobile platform right now, but I want you to pay attention to this face right here, which matches this guy. Look at how different that face is. Let me show that again. Okay, so not just capturing the facial performance, but from a plain RGB camera feed, actually capturing the face. How does the model of the face show up? Okay, now again, nothing that's running on a mobile device today, but in the future, maybe by the time you guys are looking for jobs, this might be something that could be running in real time in a metaverse experience. Okay? So, machine learning, huge part of the future of the metaverse. Any questions on that? All right. Another piece of the successful recipe for metaverses, in my opinion, is what I'm going to call volumetric streaming. Microsoft has come up with a term, we call it holoportation, but it is basically the real-time streaming of a thing somewhere else. Okay, this is a video from a conference last year. This is James Cameron, and this was a conference, that we did in 2021. I'll just play it for just a moment.
Can be done. Now you start overlaying into that data sets of animals that have been seen, maybe squid schools that have been seen on sonar, that sort of thing. Say, this is what we expect to see at this depth.
Look at this
so our researchers can plan their work. But the beauty of it is that they can bring the audience along with them. Now, sure, it'll be a...
Okay. Now, this was a very early version. This is live code. We actually did an event with, I forget how many thousands of people where we did this live. Okay, this is an early version. Where everybody seems to want to go in the future is full volumetric streaming. That's going to require a lot of work. It's going to require some machine learning. It's going to require unique ways of capturing data, streaming data. Let me show you a research paper that can kind of give you an idea of where this is going. So the video that I just showed you a moment ago on stage, that was more of like 2D objects in 3D space. Okay, this again, not live, but a research paper.
And the output also looks like a question.
Back it up just a second.
Smoke plumes and more. But if you look here, this part begs the following question. The input is an image and the output also looks like an image, and we need to make them similar. So what's the big deal here? A copying machine can do that. No? Well, not really. Here's why. To create the output, we are working with something that indeed looks like an image, but it is not an image. It is a three-dimensional cube in which we have to specify color and opacity values everywhere.
Okay. The way I like to describe this is imagine that this cube is like a block of stone, and what the software is trying to do is carve it into an object and color it to look like the original object. Okay, so we have a subject, we've got a bunch of different camera angles, and we are dynamically creating a volume that represents the original object. And if we can do that correctly, then we get some interesting output like this.
And the coolest part is that...
So now we have a true novel object of the subject, theoretically in real time, that could be viewed from any angle. Okay, so where does this fit in? Imagine that you've got concerts where you want to have the real performer, like mixing on the DJ stand or singing or playing the instrument, right? Streaming that whole thing as a three-dimensional object where as you walk around the stage, you can see them from every angle. Okay, so again, career-wise, this is machine learning. This is shaders. making stuff run on the GPU because you're going to have to decode that stuff and turn it into a 3D object very fast. It is video compression. It is video capture. There are lots of interesting things here for just this one piece of what metaverse entertainment is going to become. Let's switch gears for a second, and I want to talk about monetization, because obviously for these metaverses to work, somebody's got to make money off of it somehow, right? And what I hear a lot is everybody just says, oh, blockchain, done. I don't know how many people here are interested in blockchain. Blockchain is a technology, and blockchain can be used to solve many of the problems in metaverses, but there's still a lot of work left to do, careers that can be had to figure out how to marry these two technologies up. So, first thing that everybody thinks about is I buy a thing, I buy a t-shirt for my avatar. Later, I have to prove that I own it so that my avatar can wear it. That's called proof of ownership, and blockchain does that easily. But who owns the ledger? Right? Like at the beginning, I said we've got Meta, Microsoft, Google, Apple. Do you think that Google's going to say, oh, we'll just use Apple's blockchain? No. Right? It's not going to happen. They're all going to start with their own. So now you've got blockchain to blockchain communication and transfers and all that kind of interesting stuff. Blockchain doesn't equal currency. I had a conversation at dinner the other night with somebody about concerts, and they were arguing that Roblox is a metaverse, and I said, can you go to a concert in Roblox? I said, sure you can. I talked about the previous thing about the holoportation. I said, how would you pay for that concert? Well, you'd sign into Roblox, and you'd buy Robux, and then you could buy your ticket at the door. And I'm like, who's going to do that, right? Are your parents who want to go to a concert going to go buy Robux? No, they're going to want to rip out their Visa card, right? So just because this whole system is backed by a blockchain doesn't mean that that's the currency of the blockchain, or of the metaverse. All right, I know that was short. I'll talk a little bit more about the monetization. Nobody knows what's going to make the most money, right? Is it going to be concerts? Is it going to be paying for entrance to a virtual museum? Is it going to be entertainment? Who knows? I think it's pretty hard to guess right now, like it would have been pretty hard to guess back in Web 1.0 that Uber was going to be a thing. So, I'm talking about the career that you could plan for that would help you be in this space to be the ship for the monetization. All right. Now, many of you here, maybe not all of you, but I think most of you here are comp sci development, software development. Okay. So let's talk a little bit about extensibility, because I think this is a problem that most people don't realize how large this problem really is. This is a picture of Unity. And honestly, not a very complex scene. This is a screenshot of a Unity scene out of the Mixed Reality Toolkit that lets you play around with some physics objects, like pick up a cup and some blocks and play with some buttons. But look at how complicated the scene is just for this, right? If you're building your metaverse on top of Unity and you want to make your metaverse extensible, you can't just go give your developers access to your Unity scene. Bad stuff will happen if you do that. For example, then some developer could just go read your avatar data. They could just figure out what your username is, or maybe private personal information about the user that avatar represents. How about hijack the buy button? There's a buy button to buy tickets or a t-shirt, and they just replace it with their own pop-up that looks like a valid place to put your credit card. It's not a good idea, right? They could insert ads that you don't want to see. Monitor user activity. To me, if you were to give your developers access to the Unity scene, that would be like giving Chrome extensions the ability to do anything that it wants to the Chrome browser. Just replace the file print menu item with whatever that Chrome extension wants that file print menu item to do, right? So to make an extensible metaverse, as developers, you have to think differently. Like, you may be learning Unity, you may be learning C#, but in your career path, you need to be going into like advanced engineering, advanced software engineering, where you think about patterns like extensibility, where you think about how do I make code run in a sandbox? How do I make sure that this code only has access to these 10 objects and can't touch anything else in the scene? Okay? You got to really think differently about the way that you allow people to write code in your environment. So here's Jared's personal extensibility goals for metaverses. I think they need to be safe and isolated, what we just talked about. I think they need to be easy to create. And honestly, I think too much of what's there today is too hard to create. Yeah, you guys may not have a problem pulling up Lua, but the average person is not going to go learn Lua to extend a metaverse. It's too hard. So I think it needs to be low code, and ideally, I think there should be no code options. I'm going to talk about portability in a minute. I'll have a bullet point here. But here's a thought experiment. Who's used if this then that? See one hand.
Oh,
Okay. Stupid simple automation. It's like if I upload a YouTube video, then post about it on my Twitter channel. If I receive an email message, then send me a text message. If I walk in the front door, turn the kitchen light on. Those are all things you can do here. What if your metaverse extensibility was like that, right? Like if thing hit play sound. Anybody could do that, okay? That's where I want to see the development go. So again, you as a developer may be learning C# and Unity, but you need to think about how to build runtimes that can support this level of user customization. All right, artifacts and accessories. Accessories are things that your avatar might wear, like a watch, t-shirt, that sort of thing. Artifacts are things that you might want to decorate your space with. Furniture, games, basketball, that sort of thing. Okay? So what are some of the goals for artifacts? Well, if we want to sell stuff, being able to validate its authenticity would be cool, right? Like if Nike actually wants to sell shoes or Gucci wants to sell handbags, being able to digitally authenticate that it was created by Nike or Gucci would be a valuable thing. And guess what? We have blockchain again. It's called proof of work in this case. Proof of who created the thing. And oh, by the way, another neat feature about blockchain and proof of work is that the creator can set a fixed number of items that will ever exist. So Nike can say, there will only ever be 5,000 of this shoe, period, done. And when they're sold, they're gone, right? Even though it's a digital asset, now there's a finite number of them, now they have increased value. But value is limited by portability. What do I mean by portability? Well, we already talked about the companies that are building metaverses. What if I buy something in Metaverse A and I want to go to Metaverse B that happens to be owned by another company? If I can't take that with me, much less valuable, right? Like, can you imagine buying a t-shirt from your favorite band at a concert and then you can only wear it in certain stores? You wouldn't buy it, right? Like, that's silly. So when I talk about portability, I'm talking about, and this is on the companies that are building these metaverses and why that open standards forum exists, is like, how do we make these things where they could potentially leave a metaverse and go with you to another metaverse? But that is a hard engineering problem, guys. Really hard engineering problem. I put a couple of things down here like physics, sounds, and interactivity. Artists, I don't know how many of you are lucky enough to have an art major on your teams, but the art tools like 3D Studio or Maya, you don't define physics in that tool. You don't define sound effects in those tools. You don't get to define those things until you bring those art assets into your engine like Unity. But then guess what? The way that Unity defines physics is different than the way that Unreal defines physics. So how do you create these assets in a way that they can be portable to different metaverses and different engines? It's a very interesting engineering problem. What this boils down to is you have, as you're building this software, you have a platform that you're building on top of, like Unity or Unreal Engine. But you have to describe your objects in a kind of engine-neutral way so that it could go somewhere else and be realized somewhere else. And it may not look exactly the same, but it gets as close as possible to the description. Okay, and that's part of what that Open Standards Forum is going to be working on. Interactivity, this goes back to that rules-based stuff I just talked about. What about durability? What do I mean by that? Well, this is something that Microsoft learned a little bit about through AltSpace. Turns out that we made it pretty easy for people to go and create worlds. But guess what? People aren't around forever. They may get bored. They may, unfortunately, get hit by a bus. If you have built your engine and your worlds in a way that it depends on a certain version of Unity, for example, and then later you just decide, oh, we're going to go to Unity 2025, and now Unity 2025 doesn't support that feature anymore, then either that original world creator has to come back and convert their world, or that world goes away. Right? So when I talk about durability, again, if you can architect it and build it in a way that you take a step back, you don't take dependencies on your engine, but you do descriptions that get translated to your engine, now you have a path forward to up-convert to whatever engine you want in the future. Okay? Again, different kind of engineering thought process in building software. All right. I have a fun one for you. I hope you guys all know what CSS is. Any web developers here? CSS and style sheets? Okay. One of the really cool things about style sheets early on in web development is, like, remember the vendor-specific stuff? So there was like Mozilla Dash and Firefox Dash and I forget what all the prefixes were. What that did is that allowed each of the vendors to go and create their own definition for rounded corners or background colors or whatever before that became part of the standard. What if we did something similar in metaverse development? Like, what if a sound effect was a tag or a physics attribute was a style that could be applied to an object? Now, this picture I'm about to pull up is not, again, it's a comp. It's not a real thing. But imagine that you could have a plugin to Maya or Blender that would let the artist pick part of the object and just apply metadata attributes to it. Like, this thing's made out of wood. It's this dense. It plays this sound when it's hit. And that metadata just gets baked into the object file, right? GLTF. And then all of the different metaverses could load that. I think that would be really cool. Because then not only are you, again, you're not taking a dependency on the engine, but you're actually empowering the creativity of the artists that don't traditionally have the ability to do these things today. And I think that would be really cool. All right. Does 2D matter anymore when it comes to the metaverse? Do screens matter anymore when it comes to metaverse? I see some nodding, some shaking their heads.
Especially like in the presentation you showed, only the people are
So what he's saying is, from a contents perspective, we still need 2D, right? I'm more talking the other way around. The whole engine itself. Does the engine need to run on a flat screen? And the data that we have says emphatically yes, it does, because that is today your means of scale. Everyone has a phone. Everyone has a laptop or a tablet. Okay? You can reach way more people by supporting flat screens than you can by requiring a VR headset. So it's not an either or, it's an and. And as you are developing your stuff, I think it's very important for you to keep in mind both. You need to not only be able to support a fully immersive experience, but you also need to be able to do it with keyboard and mouse. And make sure that you're designing all of your user experience to be able to support that. Okay, what about VR versus augmented reality? This one's much harder than you think. I'm going to show you 2 videos and a slide deck to explain why. There is a thing in augmented reality called co-location. And let me play a couple videos real quick to demonstrate. This first video is of an app called Microsoft Mesh. It's a simple little app that we built. It runs on HoloLens 2. Okay, just to give people a taste for what Mesh could be like in the future. Okay, in this video, we have one person physically in a room, and we have another person who is joining from a different place entirely. So notice this table here. The table is important because the table is the center of the world. And so you see an avatar because this person's not in the room. They're somewhere else. But they can hand objects to each other. They can see the same content. Everything is relative to that table. Okay? Now, same application, but in this example, we have 2 humans physically present in the same room. Watch what changes. No avatar, but look above her head. You still have user information above her head that follows her when she walks. When she starts to draw, we can see the ink come out of her fingertips. Okay, so how does that work? We're going to be talking about the second part, right? Or actually, I'll walk you through both of them. So we start the application, and we've got John and Mary. They are both in the same room, but we're going to make an important decision as we start the app. So John is standing next to this first table. Mary's standing next to a second table. Oh, and we've also got, I guess, Joe. Joe's room. To both of them. Okay? So when you start this application, and this is a real application that you can play around with on HoloLens today, it says, are there other users nearby? Like in the same physical room? And if you say no, then what happens is this. Then Mary has her own table, and because we've said nobody else is in the same space with me, then we get John and Joe show up as virtual people. We see their avatars. And oh, by the way, John sees Mary as a pink avatar, right, in the room. So now there's 2 Marys, one avatar Mary and one real Mary, and that's not what makes sense. So if we go back and instead we say, yes, there are other people in this room, then what happens is the HoloLens starts looking for things that are recognizable in the room. It looks for the chair. It sees a plant. It sees a window. And it recognizes these things, okay? John's HoloLens does this, and Mary's HoloLens does this. They both do this. Now, because they're both in the same room, they both know where those things are, right? To John, the red chair is forward and to the left. Well, I guess that's true for Mary as well, but you get the point, right? Both of these devices know where these things are. They're at different locations. So watch what happens. I'm going to play an animation. It's going to go quickly. If we know where these 2 different worlds are, then we can just line them up, right? We could just slide the 2 tables to be in the same physical place. And let me play that again. When we move Mary's table to the left, then John's avatar comes to the right, or vice versa. Okay? So now Mary's avatar physically lines up to her body because we've moved the table. Remember, everything's relative to the table. So then Mary can now walk over the table. When Mary walks over to the table, her avatar goes with her. But now it's silly that we're rendering the avatar because Mary's there, so we don't need to render the avatar. So we don't render the avatars for the 2 people that are physically present in the room. And then the amount of data that we need goes way down. We don't need to send hand finger positions. We don't need to send facial expressions. We just do the little sign of the username above their head, right? Okay, so I show all of this to you. Oh, there is one more slide I was going to show here. By the way, the way that HoloLens does this is pretty amazing. We use a technology called Azure Spatial Anchors. It runs on HoloLens, it runs on iPhone, it runs on Android, and it auto syncs across each of them, right? So if I can recognize the plant with Android, I can recognize the plant with iPhone, and I can recognize the plant with HoloLens. And the way that we do it is through this technique of fingerprinting. We don't actually store photos on the server. We store mathematical numbers that only make sense when you're in that space. But the reason why I show all of this to you is to let you know that augmented reality is far more difficult than virtual reality. In virtual reality, the middle of the world is Unity 000, and that is true for everyone. In augmented reality, the middle of the world is, who knows, where you turn the device on, where you launch the app. Like, somehow you've got to get those people agreeing with each other. And that is not an easy problem to solve. When you do solve it, some cool things could happen. There is this, what are we doing here? There is this concept that I've heard thrown around called channels. What is a radio channel? What is a radio station? It's, if I turn it on 94.5 and I hear a song and you've got your radio on 94.5, you hear the same song playing at the same time, right? Imagine the same thing for augmented reality content. Let's say that I'm at Disneyland and my son and I are on the Star Wars channel. And I've got my augmented reality glasses and a TIE fighter flies overhead. He and I would both see a TIE fighter flying overhead at the same point. And my daughter happens to be on the Sleeping Beauty channel, and she sees the evil queen standing there in front of the castle, right? But in order for a concept like this to exist, all of those devices have to agree on the alignment of the world, which means we basically have to kind of map the whole world, and that is a really difficult problem to solve. Okay, so you got to do 2D if you want reach. 3D is going to come next. Augmented reality, we will get there. I think huge value when content is available wherever you go. Also, monumental engineering problem to get there. And plus, AR devices are way more expensive and much harder to buy. Okay, so back to programming. Engines, we're getting close to the end here. What engines can you use for metaverse development? Well, you all know these two. Unity and Unreal, the same ones you use for VR. You can do it for AR. You can do it for 2D. But there's another one that I want you to think about, which, going back to the web analogy of Web 1.0 to Web 3.0, well, on the web, we have this thing called a browser, right? Where nobody writes browsers anymore. You write pages. And that's where I start to think of these kinds of engines, whether it's AltSpace or VR Chat, as like browser 3.0, if you will. Okay? Place to load content. Now, these engines, these browsers, are going to probably be built on one of the other two engines, right? They're probably going to be built on Unity or Unreal. But the point is, you're creating a layer that can load content that is accessible to everyone else. Okay, so career-wise, do you want to go down the path of being the engineer that's building the engines? So like you're going to learn Unreal or Unity and you're going to go to a company and build the engines? Or do you want to look for a company who's already built an engine and you're going in and your job is just to create worlds, to create content, right? Those are both going to be lucrative career paths. As you are watching this space unfold, as you're watching these engines come out, because there's going to be 100 of them or 1,000 of these engines, keep these ingredients in mind. Whatever engines give you these ingredients, I think, are the ones that are going to be successful in providing the greatest variety in metaverse space. Now, I am not part of Microsoft recruiting, but I will tell you that we are hiring right now. We've got about 15 open jobs worldwide for Mesh as of this morning, 25 in mixed reality in general, which includes HoloLens, and 15 specifically on HoloLens. So at any point, if you're interested, you can go out. I know that will probably continue to ramp up, I would imagine, over the next few years while you work towards graduation. So these skill sets will be applicable, and if you can become, highly skilled in any one of those areas, you will, I believe, be able to find a career at one of those companies. That is it.